Hello, good morning, little scientists. Welcome back to another science session. Today is Monday, April 20, 2020. Our lesson name for today is titled Thermal Energy Transfers. Our teaching point for today is I can identify and describe three different thermal energy transfer types, which are conduction, convection, and radiation. So I recommend that you pause the video now and get to work this in your notebook. So we keep on working on our energy transfer module, specifically on lesson 4, heat. In this one, we try to answer the essential question, what is heat? We're pretty close to answer this one. Let's jump in right away to the question of the day. Is the measure of the average energy of motion of the particles in an object? Will be heat, temperature, thermal energy, or thermometer? And the right one is temperature. So what is temperature? Temperature is a measure, right, of how hot or cold something is. Specifically, a measure of the average kinetic energy of the particles in an object, which is a type of energy associated with motion. We already know that this type of energy associated with motion is what we call kinetic energy. Now, when we talk about that kinetic energy regarding the particles, we're talking about that thermal energy. And we saw before that thermal energy determines actually how are these particles moving inside an object, right? It describes the movement of these particles determining how hot or cold this body is. So in order for us to measure how hot or cold these particles are, we use a concept that is called temperature. So going back to our teaching point, which is I can identify and describe three different thermal energy transfer types, which are conduction, convection, and radiation. We're going to watch a short video right here where we get to see a real life situation on how this works. So let's take a look.
What do helping your parents cook noodles, sweating on a hot day, and warming your hands on a cup of hot tea all have in common? They all involve the transfer of heat, a form of energy that travels from warmer to cooler objects. Let's explore the three ways you can transfer heat from one source to another: conduction, convection, and radiation. Conduction is when heat transfers from one place to another through direct contact. Think about the last time you had a bowl of hot soup. You put in your spoon and then maybe dropped in some crackers. When you grabbed your spoon, how did it feel? It was probably pretty warm. Why does this happen? The spoon was warmed up by the heat of the soup, which transferred that heat through direct contact to the spoon. When your hand touched the spoon, the heat transferred up to you. Metals, especially copper, can be good conductors of heat. Copper is especially popular with cooks because it has the ability to spread heat evenly. When you cook with a non-copper pan, the heat starts directly where the flame of the burner is and then moves out across the cooking surface. In doing this, you have some areas that are hotter than others. A copper pan conducts the heat from that flame evenly across the entire pan. Because of its ability to conduct heat, copper also heats quickly. While conduction is a direct transfer of heat, convection transfers heat using liquids or gases. Say you are home from school and hungry. You ask an adult to help you make some mac and cheese. The first step is to get some water boiling. They fill a pot with water and set it on the stove. As the water heats up, the water that is on the bottom of the pot, closest to the heat source, will get hot first. Hot water is lighter than cold water, so as it gets warmer, it rises up to the top of the pot and pushes the cold water down. During this process, some of the heat in the hot water is transferred to the cooler water. When this cooler water sinks to the bottom of the pan, it heats up more, and soon it is moving back to the top. As it does, it transfers heat to the water around it. That process of water going in a circle, heating other water as it rises, is an example of convection. This same process makes a hot air balloon soar across the sky. Underneath the big balloon, you can see a flame. This flame heats the trapped air, forcing it up inside the balloon. As it heads up, it pushes the colder air down. This movement of the hot air up and the cold air down is another example of convection. The hot air at the top of the balloon is the lighter air, which makes the balloon rise. The third type of heat transfer is radiation, which is the transfer of heat in the form of waves. Say it is the middle of summer and a really nice day, so you decide to walk to a friend's house. As soon as you get outside, you start to sweat. You are feeling the radiant heat from the sun. It is sort of like making s'mores over a fire pit or campfire. You have your marshmallow at the end of a stick, and you are heating it up over the embers of the fire. The closer you get to the fire, the warmer you get too. Remember though, never get too close to an open fire. It is the same with radiation. We cannot see the radiation, but we certainly feel it on our skin. Which heat transfers have you experienced today? How would your life be different without conduction, convection, or radiation?
Right, so right there we have the opportunity to actually take a look at how these three might look like in real life. So what can we share about conduction, convection, and radiation? So right here I have a chart actually where I list different features that we can actually keep in mind when we're trying to identify these three different types of thermal energy, right? So the first one is conduction. In this one, the energy is transferred by direct contact. So that means that the two objects are touching each other. If they are not touching each other, then we don't have a case of conduction. Right, in this case, the energy flows directly from warmer object to a cooler object. Right there we saw different cases where we have frying pans and these were touching the stove, right? So this stove were transferring energy, the warmer object, to the cooler object, which is the frying pan in this case. It can also occur within an object, so that means that it doesn't necessarily need to happen from outside to inside, but it can actually happen inside the body. Alright, it actually continues until object temperature are equal. So let's take a look at that last feature later on. Then we have convection. This one occurs mainly in gases and liquids. So whenever we have heat being uh, or actually impacting gases and liquids, then we have a case of convection right there. This actually is the movement of a large number of particles in the same direction. It happens with the liquids when we have the warmer liquid actually pushing the cooler liquid because it's lighter. Being this way, easier to move. The same thing happens with the gas. We have the warmer air pushing down the cooler one, actually pushing it out. So the next one that we have is occurs due to a different in density. So when we try warmer gases and warmer liquids, then these are way lighter. So that means that their mass is reduced. So that means that their density is actually different, is less. So its cycle occurs while temperature differences exist. So as we watch in the video, we have these liquids and gases pushing the cooler pieces of these particles in every case. So this convection thing will happen until we get the same temperature. Since we don't have, since when the temperature is the same, we don't have any warmer object or any cooler object, then that means that they're the same, they're in balance. So they're not pushing each other out. And then at last we have radiation, in which the energy transferred is transferred by electromagnetic waves, such as light, which we can actually see, microwave, and infrared radiation energy. These two last we can actually see it because are not inside the visible spectrum, right? So there we have that all object actually radiates some kind of energy. We can actually see them all or perceive them, but in this type of thermal energy, we can actually perceive it as heat. It can also be transferred through empty space. We saw before that waves need a space and medium to actually travel. In this case, radiation doesn't need any medium to travel. It can actually travel in empty space and in a medium as well. Alright, so we can have the opportunity to actually practice a little bit more on these three concepts. I created the toy activity for you. So you are going to see the link in the PDF where you actually found this link as well. You just need to copy the link and copy and paste it in your URL direction right on top. Then you're going to be working on the page 70 from your science book, which is the next activity that we're going to try now. Right there you have the situation where you have a stove with a frying pan and some water boiling, and then you have a toaster. So right here you're supposed to actually identify and label the different type of energy transfer that we have. The first thing that we need to take is to actually take a closer look at the interactions that they're having. If we pay attention to the first one, we have these two objects touching each other, so there's contact between them. We have the warmer object, which is the stove, and then we have the cooler one, which is the frying pan just before it got hit. So we got the stove transferring energy into the frying pan. So since they're touching each other and we have a cooler object transferring energy to a warmer object transferring energy to a cooler one, then we're in presence of a conduction type of energy transfer. Now, in this case, we can actually see that is convection. Why convection? Because we have this water boiling when we have the warmer water pushing our cooler one out. We can actually see at the very top that we can also have some hot air coming out of this in the way of evaporation. So this one we're going to label it as convection. And then at last we have radiation, which is the energy that comes from a source, in this case the toaster, in the forms of wave or particles. So you can see right here that is actually emanating some radiation to the bread. So that's it for today, guys. I hope that you have enjoyed this lesson. Don't miss the toy activity because I know that you're going to enjoy playing around with this concept. So see you next time.